and there is not just one way of solving this particular problem. But then here we have to just take care of certain things. First thing, let's just find out the kinetic energy fast, okay? And the kinetic energy is actually nothing, it basically has got. So if you just read the question, we basically have a particle of mass m is free to slide on a thin rod where. Okay, so sometimes the image might be given, you have to make the image, so you have to basically imagine what will happen. And then it said that the wire is rotating in a plane about one end. Okay, so we have got it fixed at this particular end. Let's say O is the origin, which is of your own choice, at constant angular velocity. So this is the constant angular velocity that we have. You have to obtain the solution of motion for the free particle. For this term, ignore the gravity and friction plays a very important role, because if we say gravity is not there, we are ignoring the gravity, the potential energy can be considered to be zero. Okay, and that means that we are actually going to use only the kinetic energy to solve the problem. So what happens here is we'll just write down the expression for kinetic energy. Okay, so let's just try doing that first. So this will basically have a component of velocity along this direction as well as in this direction. So this will be because of the rotation. So this is v theta, and this is nothing but vr. Right? This is vr. So let's just solve it. So that means that I can actually write it down in terms of vr square plus v theta square. Now when we write down the Lagrangian equation of motion, we have to write it down in terms of the generalized coordinate. The generalized coordinate is r and theta and not vr and v theta. So that means this vr and v theta, we have to write it down in that way, right? So this is your, maybe I'll just explain it here. Okay, that's important. This is radial and this is the angular component. So what is VR? VR is dr by dt, right? The rate of change of the position coordinate with respect to time, and that's why we can just simply write it down as dot. Right? And I think v theta we already know. V theta is equal to nothing but r omega. We are considering the rotational component. So if you want to write it down in terms of angular velocity, v is equal to r omega. Angle is 90 degrees, so that means if you take the cross product, it's sine 91. So you can just take it that way. And then this is r, and theta is the generalized coordinate. So we prefer writing it down in terms of theta and not in terms of omega. So which is nothing but theta divided by dt. So that means we can just simply write it down as r theta dot. So now we can just replace it. So in general, we can say that T is equal to half m. And then this is VR, is r dot square, plus v theta is r theta, so it will be r square theta dot square. Okay, so that's your kinetic energy, and then potential energy is 0. Okay, so no gravity, no friction, so that's why it's given. Okay, so sometimes you have to read the question carefully so that you get it clearly. So L is equal to T minus V. So this is a problem which we have, I think, solved yesterday. Half m r dot square plus r square theta dot square. Okay. So if we have this, we can actually solve it to actually find out the Lagrangian equation of motion, and maybe we can quickly. This can be done quickly. So I will just take del L del r dot minus del L del r is equal to 0, right? So if you just do it quickly, this is the dt. So del L del r dot. So this is the only component we have it. So it will be 2 r dot. 2 gets cancelled. So we can just simply write it down as m r dot. Minus del L del r, we have an r here, so it will be twice. Okay, so 2 gets cancelled, so it is m r dot square. Okay, dot square is equal to 0. So if you just simplify this, okay, just take out m common, then there is a 0 on this side. So we can just cancel it out. I'll just do it in short. Okay. So the m gets cancelled out. That means can simply write it. DDT of r dot is r double dot. So you can just simply write it down as r double dot minus r theta dot square is equal to 0. Right? And what is this theta dot square? You know, theta dot is nothing but omega. Okay. So we can simply write it down as r double dot minus r omega square is equal to 0. So this is actually a second order differential equation. If you just write it down, okay, more specifically in terms of the differential form, d2r dt square, okay, minus r omega square is equal to 0. You know, if you are asked to write down the solution equation of motion, this is the equation of motion that you have, okay, and then suppose the question asks what is the solution. You know, you write down the equation of motion and find out the solution of that. Now this is actually a second order differential equation. You can actually look into your maths book to see the approach how it is solved. Typically when you basically have a second order differential equation, okay, I just prefer doing it on the same slide. So if you just write it down as d square y, let's say d square y dt square, okay, minus r omega square differential equation. This is the second order differential equation. For any such equation, your solution will be nothing but a to the power minus cx. You can use any constant, okay, doesn't matter. E to the power cx. So this is basically the solution for this differential equation. So if you just look into this, as Srijita said, this is the thing that we are going to get, right? So you are basically solving it for r, which is actually a function of time, is equal to e to the power minus omega t plus b e to the power omega t. Okay, so you know, this will be actually the solution. So if you just look into the final answer of this, this is something we asked for. We're supposed to do this, and this is actually only halfway. But then, you know, you can actually solve it and show it. But then this is something which is standard for the second order differential equation. You just directly write down this also, it's fine. So let's say it's a 2-mark question or a 3-mark question. It doesn't make much sense that you try solving this and writing down the entire solution there. Okay? It obviously depends on the question, but you can always look into your differential calculus book and solve it and check